Imagine studying a giant redwood tree. You could climb it, measure its trunk, and count its needles, but what if you could study the entire forest from above? That's the power of remote sensing. It's how we study our planet from afar. We use instruments to observe things without touching them. Remote sensing relies on energy. Objects reflect or emit energy like light or heat. Sensors detect this energy. We then analyze the data to understand the object. It's like taking a picture with information beyond what our eyes can see. Think about how doctors use X-rays to see inside the human body. Remote sensing is similar. We use different kinds of light to see through clouds, vegetation, and even the Earth's surface. This technology reveals the hidden patterns of our planet. It's a powerful tool for understanding our ever-changing world. There are two main ways to see remotely passive and active sensing. Imagine you are in a dark room. Passive sensing is like seeing objects illuminated by a lamp. It detects natural energy that's reflected or emitted by an object. Sunlight is a common source for passive sensors. Our eyes are passive sensors, so are cameras on satellites that take pictures of Earth. These images show us everything from weather patterns to the growth of cities. Active sensing is like using a flashlight in a dark room. It sends out its own energy signal and analyzes what bounces back. Radar and LiDAR are examples of active sensors. They can see through clouds and even map the ocean floor. Each type of remote sensing has its strengths. Passive sensors rely on available energy. Active sensors can work day or night and penetrate different materials. Together, they give us a more complete picture of our planet. The applications of remote sensing are as diverse as the universe itself. In agriculture, farmers use it to monitor crops. Special cameras on drones or satellites can detect plant health and water stress. This data helps farmers use resources more efficiently and increase yields. Climate scientists rely on remote sensing to track changes in our environment. Satellites monitor glaciers, measure sea levels, and track deforestation. This information is crucial for understanding and mitigating climate change. Urban planners use remote sensing to manage the growth of cities. They can track urban sprawl, monitor traffic patterns, and plan infrastructure improvements. This helps create more livable and sustainable urban environments. Disaster response teams use remote sensing to assess damage from natural disasters. Satellites and aerial imagery provide rapid situational awareness after events like earthquakes, hurricanes, or wildfires. This information is crucial for coordinating relief efforts and saving lives. Section 4, the Remote Sensing Toolkit, Satellites, Sensors and Software. The tools of remote sensing are constantly evolving. Satellites are like our eyes in the sky, orbiting Earth and collecting data from space. They come in all shapes and sizes, each designed for specific missions. Sensors are the eyes of these satellites. They detect and record different types of energy, such as visible light, infrared radiation, and microwaves. Each type of sensor provides unique information about our planet. Once the data is collected, we need to make sense of it. That's where Geographic Information Systems, or GIS, come in. GIS software allows us to analyze, visualize, and interpret remote sensing data. We can create maps, three-dimensional models, and other visualizations to understand complex phenomena. Drones or unmanned aerial vehicles are becoming essential tools for remote sensing. They provide high-resolution images and data for specific areas of interest. Farmers use them to inspect crops, and engineers use them to inspect bridges. Section 5, the future is now remote sensing in the 21st century and beyond. The future of remote sensing is bright. Advancements in sensor technology, data processing, and artificial intelligence are revolutionizing the field. We can now collect and analyze data at unprecedented scales and resolutions. Miniaturization of technology is leading to smaller and more affordable sensors. This will make remote sensing accessible to a wider range of users, from individual researchers to citizen scientists. The increasing availability of open-source data and software is democratizing access to remote sensing information. This will empower communities around the world to address local challenges using geospatial technology. As our planet faces unprecedented environmental and societal challenges, remote sensing will play a critical role in monitoring changes, managing resources, and finding sustainable solutions. It's a powerful tool for building a better future for all. Section 6. A call to explore the uncharted territories of remote sensing. We've come a long way since the early days of aerial photography. Remote sensing has revolutionized our understanding of Earth and its intricate systems, but there's still so much more to explore. The vastness of space holds endless possibilities for remote sensing. We can use these techniques to study other planets, moons, and celestial bodies. Imagine mapping the surface of Mars, searching for signs of life, or studying the atmospheres of distant exoplanets. As we venture further into the cosmos, remote sensing will be our guide, helping us unravel the mysteries of the universe and our place within it. The cosmos awaits, and remote sensing is our key to unlocking its secrets.